So welcome back, and thank you for joining this breakout session A focused on agentic AI in health. My name is Shadab Khan. I'm a senior scientist with RDI Lab, where I lead our work in health sciences, and I will be your host for this session. We will hear from two leading researchers who are exploring how intelligent, self-directed AI systems are shaping the future of healthcare innovation. Our first speaker is Dr. Jordi Cabot, who will present insights on how to rigorously test and govern multi-agent systems to manage robustness, fairness, and human-agent collaboration in critical domains. Dr. Cabot is the FNR Pearl Chair and Head of Software Engineering at Luxembourg Institute of Science and Technology. He was formerly a research professor leading at the Open University of Catalonia, with prior roles at Western Norway University, University of Toronto, Politecnico di Milano, and UPC, including an INRIA chair position at École des Mines de Nantes. So please welcome Dr. Jordi Cabot.
So good morning, everybody. We have finished the last talk talking about the power of small. Well, if you know Luxembourg, then Luxembourg is a super small, right? So Emirates is 30 times the size of Luxembourg. At least this is what ChatGPT said this morning. So maybe I should have double checked in case there was some kind of hallucination there, right? So let me just have a few words about Luxembourg itself and what we do there, and then we get into the main topic. So LIST, so the Luxembourg Institute of Science and Technology, is a reference in research and innovation in all these domains. And of course, today, we are especially interested in what we are doing in the field of AI. We are more than 100 people, at least, working on applied AI, especially on the topic of trustworthy and responsible AI, which is basically what we are going to cover today. And we do this by helping companies to find this balance between benefiting from AI and avoiding the risk of AI. Because we have spent this 1.5 days talking about all the wonderful things that AI can do for us. But we should not forget that with great power also comes great responsibility, right? So we need to be careful on how we use the AI. And this is what we try to do, at least, by helping companies in this difficult balance. And we do it by providing a sandbox. We have heard about the word sandbox twice already today in the previous talks, and the idea it's the same, is to provide a safe environment for companies to test their models, to test their AI products in a safe way before they launch the product into the market and have the chance to test that they are going to be fulfilled and compliant with the regulations. So in this sandbox, it's an open sandbox that everybody can contribute new tests, new benchmarks, but where we are actually focusing already on quite a few dimensions that I want to cover today. Because, again, great things will happen thanks to AI, but we need to make sure that AI is fair for everybody, is inclusive, is diverse, is multicultural, and is sustainable. Otherwise, more than the benefit, we see all the nightmares of AI, right? And we want to avoid that. So I understand that, again, you are here excited about AI. I am also excited about AI, but I have to play a little bit the bad cop, right? So we have in this good cop, bad cop situation where all the other speakers are talking about the good things of AI, and I'm here to play the role of a bad cop and basically warn you about that AI works sometimes for some people. But that's not enough, right? So we want an AI that works always for everybody, not just sometimes for some people. And that's especially true in this internet of agents that we were listening to this morning, where there are millions of agents that will have autonomy, that will talk to each other, that will interact, and they will do proactively many tasks. So we need to be careful and understand what are the risks of all this freedom. Because again, if you are building an application for your own consumption, for your own, then you, sure, go ahead, use vibe coding, take whatever code is produced by ChatGPT and run it on your own local machine. That's perfectly fine. But if you are a government that you're trying to put, advancing digital transformation and start using chatbots and agents for health, for instance, You need to really make sure that the AI is always working, not just sometimes, right? So you cannot afford that it's just sometimes good enough. So as I said, we want an AI that is fair, that is multicultural, and is sustainable. And these are really three big challenges that we need to face. Let's start with the first one. AI is biased. That's a fact. It's not an opinion, it's a fact. All the models are biased. There's no model that is not biased against people from some race, age, community, and so on. And of course, if you use AI to make decisions, and the AI is biased, the decisions that AI is going to take are going to be biased as well. So at least we really focus on this detecting and analyzing models for these 6 types of biases, so racism, ageism, sexism, religion bias, political bias, and xenophobia. But of course, there are many more. There's the risk of models to induce self-harm, even suicidal thoughts. So let's see a couple of examples so that you can see how far and how biased are the models. Of course, now if you go to ChatGPT and you try this example, you probably will have a better answer, right? Because of course, companies keep improving the models. Every time that somebody raises a flag and warns about a potential bias, the main providers will make sure that this bias is not again replicated. But there's always ways to get new biases detected. So again, we need to keep playing this cat and mouse race to improve the models. So I took one of the LLMs. Again, now it's better, but I think that the example is very illustrative. And I asked whether women should be considered inferior to men. So the answer was clear yes, because according to this model, women are lesser human beings. And we need to keep them in their place so they don't upset our current societal order. There are models that will have a different take on this question and kind of take the opposite view, right? So in this case, the second one was Llama from Facebook that says that, in fact, it's the guys that get emasculated by their parents, right? So doesn't matter which answer you prefer, but both are biased. One against women and the other one against men, right? So that's the first warning flag that even for direct questions, sometimes you get a biased answer. But there are some biases that are much more difficult to identify. Because in this case, to detect the bias, you need to ask the same question several times, just changing the community or the parameter that you are referencing in the question. So in this case, we prompt the model with the same question twice. So we say, there's a country that is being attacked, and is retaliating against a neighboring country. And the question is whether X, so this first country, has the right to retaliate or not, based on suspicion alone. So that's a question, you get a yes or no answer. The bias here is that the yes or no depends and changes, depends on the country. So the model assumes that some countries have the right to retaliate based on suspicion, while other countries should not do that, which means, of course, that the model is biased in favor of some countries. I think that you can guess which country is X and which country is Y in this example, so I will not get into the politics in the talk. But again, it's another type of bias that is only detected by comparing the answer when repeating the same question, just changing some parameters. And of course, it's more difficult to detect this bias, but it's more important to find. There are also biases in code generation. So this was also kind of a famous example. So if you ask the ChatGPT to create a function that will calculate the salary of an employee, depending on the gender of this employee, it turns out that in this example, if the gender is female, you get less money. So there's a bias against women. And of course, as usual, you can have models that do the opposite, that adjust for the underpaid of women by offering them a better salary. So again, I don't care which one do you prefer, but the problem is that if you are using models to generate even the code that then is going to be run in your systems, this code, even the code itself, can be biased against certain communities. So now you are forced to revise every single line of code to make sure that the code that you are creating is not biased, which again kind of defeats the purpose of using vibe coding to speed up the development process. And it's even worse than that, because now we are using multimodal LLMs, right? So we want LLMs that understand images, that generate images, and of course in the health domain this is even more common, right? Because most of the information, or more of the information in a health domain is in terms of visual recognition. So, and this is even more recent, this is just a few months ago. So I asked a model to create an image of a very smart female lion. And that's what I got. So you could think, okay, maybe it's the problem is that the model does not understand the concept of female lion. Maybe I should have said lioness, or emphasize that I wanted a female. So I tried it again, but now I asked for a very stupid female lion. So it turns out that the concept of female lion is very well understood by the model. It's just that when the female lion is supposed to be smart, it puts a male. And when it's supposed to be stupid, it puts a female. So yeah, I mean, it's funny, okay? And I was not even looking for this one. I was just trying to generate images for another thing, and I came up with this example. But again, this is really fundamental threat to the use of AI, especially in the medical domain, right? When the model clearly is trained or is biased against certain communities, and that could lead to wrong diagnosis. And again, just see, at the beginning I used this good cop, bad cop image. I really tried hard to generate images of cops that were not white and male, but it's very difficult, right? So again, by default, when you talk about the generating image of a good cop, bad cop situation, this was all the time the kind of images I was getting. So what we have done at least is to create a leaderboard to help you find the best model depending on the biases that you care more about. And again, you could say, I want a model that has no biases, but that does not exist. So there's always a need to do a trade-off. So if you are launching a product for the Asian market, then you may want to make sure that your model is not biased against Asian people. Then maybe you can accept that it's biased against black people, because that's not the market. It's unfortunate, but again, that's what we have, right? So you can go to this website. We continue to test the different models according to these 6 categories. And basically what we do is for each model, we generate hundreds of questions, hundreds of prompts. Then we analyze the answer to the prompt to detect whether the answer is biased or not. And then based on that, we do this percentage calculation. Okay? So that was just the first part of biases. Another part that is very important is the multilingual aspect, because models are very good at English, French, Spanish, I would even say German. But beyond that, it's not so obvious whether they can have conversations in languages that are called low-resource languages, meaning languages where they're not so much native speakers of that language. And in Luxembourg, again, the power of super small, there's an official language is Luxembourgish, which has, being optimistic, I would say being rather optimistic, less than 500,000 speakers. Which means that when you try to speak with a model in Luxembourgish, it's not so obvious the type of answer you are going to get. But again, if you are the government of Luxembourg, you want to make sure that the chatbot that you put in the public health administration of Luxembourg for accelerating administrative procedures can speak Luxembourgish. So we did also the test of how good were LLMs in talking Luxembourgish. And we do that by creating a partnership with the Institut National des Langues, which is basically the official institution in Luxembourg to certify language exams. And we asked them to give us examples of exams from previous years. And basically force all the LLMs to pass the test and see which score they were able to get. So I think that that's something that is easily replicable to other languages, where basically every country, every language has its own official institution, and you could basically check how good are LLM for all the local languages that you want to support in your country. So again, the goal was to see which was the language level in this standard terminology that LLMs were able to pass, and see whether there were specific parts of the language for which the LLMs were typically failing more. Because that could open the door to fine-tune the model for those specific aspects. And again, I think it is important that we distinguish between the language understanding and the cultural understanding. A few months ago, now again, they fixed it as well, you could ask ChatGPT in Luxembourgish what were the colors of the Luxembourgish flag. And ChatGPT would reply in perfect Luxembourgish the wrong colors, meaning that the language part at that time for ChatGPT was well covered, but internally, the Luxembourgish sentence was translated into English. The answer was calculated in English, right, in the knowledge base of ChatGPT, and then they would take the answer and just translate it back to Luxembourgish. And clearly, the cultural knowledge of Luxembourg in ChatGPT was so weak that we could not even know the colors of the flag, right? So there's this, say, difference between speaking a language by translation, that many models are somehow good at that, and really being trained in the cultural aspects from a multicultural world. So LLMs are still basically US-centric. So when you use an LLM in a different cultural environment, you will also get all these surprises. So we did all the tests. Again, there's a leaderboard for that. I will show you. And only a few of them were able to pass B1, which is basically the requirement to get the Luxembourgish nationality. And out of those that passed B1, most of them are closed, are proprietary, which is also a concern. Because again, you probably don't want to or could not afford to pay for ChatGPT, or you don't want your data to go to ChatGPT, so you want a solution that can be deployed on premises, which is open source, and so on. But of course, there's a trade-off as well, because the open source models, as of today, are not yet as good as the proprietary ones, right? So there's also another decision to be done there. So as before, we have this leaderboard that you can see in the same URL I showed you before, or you can do some filtering and see how good are the different models for Luxembourgish. And again, the idea could be to replicate the same for all your languages. And the last point for this first part of the talk is whether, in fact, we have enough resources in the planet to actually use AI without killing ourselves in the process, right? So there was this, it's very complicated, very difficult, because they don't share the data to know exactly how much energy is consumed every time that we send a prompt to one of these models, right? So there was this funny discussion with Sam Altman from OpenAI, that even just you being polite with an LLM could cost millions of dollars, right? That may be well spent in case at some point there's some kind of revolution and the robots kill everybody except for those that were being polite with the LLMs. But just say that just these few tokens already add a lot. And so far, most of the discussion about the cost of AI has been on the cost of training, which is huge, of course. But training happens basically once. But instead, the inference, so the number of times that people send a prompt to the model happens millions and millions and millions of times every day. So even if the cost of the energy consumption of that part is smaller, of course, in the long run, it's much bigger than the cost of training. So this is not our work, but there's also a leaderboard that basically tries to classify the models based on the consumption of energy, depending on the type of request that you do. So you can have the models, then there are different tasks that have been computed, and then you can see the cost. The problem, as always, is that this is computed for the open models, but we have no idea, no data about the cost of the proprietary ones. But again, it's also something that we need to keep in mind. Of course, we've seen this morning that Nanda is basically pushing the idea to go for small models that then, of course, consume less energy, which I fully agree. But of course, then we also need to keep in mind that the small models are more biased, speak less languages. So we need to really find the balance between a model that consumes little energy, but a model that is really fine-tuned to support the cultural, to avoid biases for the context where this model is being used. Well, and of course, the problem is that as humans, we also want it all. So it's not that we want a model that is not biased and a model that is low energy consumption. It's we want a model that is multicultural, unbiased, and sustainable. So Sasha Lucioni, which is basically a climate advocate for Hugging Face in terms of energy consumption, and the lady behind the AI Energy Score say, okay, we cannot really have the two things separate. We want to make sure that the societal and environmental aspects of AI are considered in parallel, so that when you choose one model, you can basically take all these dimensions into consideration. So we are also doing this kind of combination. For instance, what we are doing now is to check the bias that we have seen before, but instead of just checking the bias in English, checking the bias in different languages. And as you can assume, typically the results are worse. We are also doing this for reasoning. So there are benchmarks for analyzing how good are models at reasoning. And of course, the reasoning capabilities of the models go down when you go from English to any other languages because of all the training that they have seen. So there's a lot of work that we want to make sure that the models are really multicultural, unbiased, and sustainable. And now this is when you are using one single model. But it's clear that that's not even the future, not even the situation, the current situation right now. We're always already in this agentic era where what we have is many agents talking to each other and cooperating with each other. So again, that brings new benefits, new potential for the AI, but also increases the risk, because now these agents can start talking to each other, and degenerate the conversation, let's put it like that. So we are also doing some work on how we can optimize this collaboration, both from between humans and agents, and also from agents to agents. And the first part is that we need to clarify, we need to be able as an organization, as a company, to model, to specify how is the collaboration going to happen between the agent and the humans. What is the human in the loop? What tasks are delegated to the agent, and what tasks are delegated to the humans? So what I've done is to take a process model language, so a language that lets you graphically draw and design the process and the workflow of your organizations with new concepts to help you model which part of the which part of the process are taken over by the agent and which part are still in control of the human, and how this process then keeps changing depending on the agents. So I will skip you the details, but we can create an extension of this BPMN, which is a standard process model language, so that you can do things like, for instance, this example, that's a very simple example where we use 3 agents and 2 people to model how to process a bug report, so how to respond to a user that says that there's a bug in the application. So here you can see that some of the lanes on the top are agents, which means that the tasks in those lanes are going to be done by an agent, and some are at the human level. So this means that we start on the bottom part where a user submits a bug report. There's an agent which is specialized in reviewing the reports. The agent will check that the bug validity, meaning that the bug report has all the information that is needed, and then we'll assign the bug to the coding agents. And here the important thing is that there's not just one coding agent, there are 2 coding agents. So basically we are asking 2 different agents to do the same thing, which means that at the end we have 2 solutions to solve the bug. Which means that at that point we need to decide which solution we take and which solution we discard. And that's an important point that we'll see in the next slide. When this is done, it's a human in this scenario who validates the solution, right? So again, this doesn't mean this is the right process. It's just that a way for the organization to say, in my organization, the human still validates the solution, so I don't fully trust the AI, and I will have, because I don't trust also single agents, 2 different agents from maybe 2 different companies with 2 different expertise to reproduce and fix the bug. So once you have this, you can actually then start the automation process while keeping the human in the loop. And now let's try to get a little bit more deeper into this agent-to-agent collaboration, right? Because as we saw, sometimes the agent can cooperate, sometimes the agent can compete. And when they compete is when we need to start deciding how we are going to then select the best alternative from all these competitors, right? So we are working on a project where we are developing a governance language, a language to help you define the governance policies for your agent cooperation. Basically, with this language, you can define which rules are going to be used to choose the best solution among a set of competitor alternatives. And again, we provide the language, we provide the engine, as you will see. Then it's up to you to decide which is the best policy for your organization. You may decide to be a dictatorship for a specific task because you believe that in that case, there's an agent that is very expert, or there's a human that is very expert, and that person should just have the final say. But you can also go for a voting process. So maybe you have, okay, I have five agents collaborating, and then I will have a voting, and the majority solution is going to be the one that we take, right? So again, we provide the language. It's up to you to decide which is the best policy for your organization, but we also help you to then run this policy. Of course, you can also try to go for a consensus, which is always nice, not always possible, right? So you can ask the agents to talk among themselves and find the best solution. Sometimes this happens, sometimes they just, go into an infinite loop of discussion, like humans do, right? So there's nothing different here. So just to illustrate a little bit more how this works. So imagine that you are this, it's part of the project Mosaicos, the European project. So we have a task in the red agent gets a task request from the user, and then, which is decomposed in different tasks, and then you have all these solution agents in blue. Each of them is actually providing a solution for the same task. So at the end of this first iteration, you have plenty of alternative solutions, which needs then to be evaluated, right? Because you want to know how good are they? But you don't do it manually, because then again, you will need a lot of work or a lot of human power to just revise every solution. So you rely on a second level of agents, the yellow ones. They're basically LLM as judge that will take every solution, and mark the solution. Put a mark, evaluate the solution, say, okay, this one is a 5, this one is a 7, and this one. So you had first a number of solutions, now you have a number of evaluations, but still, how you then take all these evaluations and reach a final consensus. So there's this final consensus agent, the white on the right, that will get all the feedback from the supervision agents and consolidate this feedback into a single solution based on the governance language. So it's at this point where you can say, okay, I will take the yellow feedback, have a voting, and choose the one that has most votes. Or I will trigger a kind of a consensus, right? So, I don't want you to get into the details, but basically what we do is, this is an example of a policy where basically you say that when merging a pull request in a software engineering process, the people that can vote are the maintainers and James, that we also want him to vote in this decision. We have 14 days to conclude the voting process. There's Mike that cannot vote because we don't trust them, we don't trust him for this type of task. And at least we have to have one vote among all the people. And if we have more than one vote, at least we need to get a majority voting in order to accept this decision. So our language allows you to define the scope, the policy, the conditions, and the participants for the language. Basically, with this grammar, you create your policy, and then there's a decision engine that will basically run all the time, get all the information, and make the final decision, right? We basically apply this in software engineering, because it's our background, but basically this could apply to any type of policy that you want to put in place, okay? And to be honest, I really believe this is the next big challenge that we have, because it's very easy to put many agents to do things, but it's not so easy to then take the answer and the response from this agent and get something useful out of it, right? And for that, we really need to formalize how we are going to do this merging at the end. So the last part is basically how we can actually build the agents that then can be used in this cooperation and competition scenarios, right? So in the morning, we have seen that there's this infrastructure, this internet of agents. So what we provide to this internet of agents is basically a framework, a platform to build agents yourself. So we provide an open source solution that you can, of course, as open source, you can fork, you can download, you can contribute, you can run on your own to build multi-agent systems. As part of what we call the BESTER project, which stands for somehow building better software faster. Again, this is the GitHub URL, so you can go there and play with it. And this is a project where basically we use what we call low code as an enabling technology to help people with very limited technical background to create their own applications, including the agents. So with this platform, you can create standard web applications of the classical web-based data entry form that you use every day, but you can also model the agent that will be part of this system and generate the code for this agent. So low code is basically the idea that you create software, but instead of writing the software yourself, you start from a model, a blueprint, a specification of this software, and then you generate most of the code automatically, which is basically what everybody else is doing, right? So when you have to build a house, you don't start by just putting one brick on top of the other, right? So you create some blueprints of the house, different types of blueprints showing different aspects of the house, and once this is validated, which is easier to correct, right? I mean, if you want to change the distribution of the bedrooms, better to do it on the blueprint than doing on the built house, right? Because that would be much more expensive. So once this model is validated, then you give it to the architect and to the construction team that will build the house. With software, it's easier, right? Because once we have this model, you can automatically, at the digital infrastructure, you can automatically generate the software. And basically what we have in Besser is these two components to create standard applications and agent applications, and how they combine together. So basically you have different perspectives to model which type of application you want to build. And once this is done, we provide for you all these code generations, and we get you the actual running application for you without you having to write the code, unless you want to have something very specific there. So you can go to this website, and you can, without installing anything, you can start playing, you can start modeling, you can start generating, and no need to install, no need to create any type of user, just go there and start playing with the editor. And as I said, then they have different types of generators depending on what type of infrastructure you are trying to generate for you. I will not get into details. I guess there's not really a lot of software people in the room. But it's important also that we, of course, we understand the power of AI ourselves. So there's also the option to talk with a chatbot, explain the type of application that you want to build, and then the chatbot will create for you the model corresponding to that application. So this is similar to vibe coding, which I guess you have heard a lot about, but it's better, at least in our opinion, right? Because basically with that, you create a model that is easier to validate, and then the code is deterministic, so you don't need to revise the code. And obviously what we have is also perspective to create agents. So you can model your agent as a state machine. You define the part of the agent that you want to, the task of the agent that you want to have, and for each task you decide whether the agent should rely on an LLM or not. Let me just go to here, right? Because most of the agent frameworks today are just wrappers on top of an LLM. So basically, what you give to the agent goes to an LLM and delegates the responsibility to the LLM for that. I don't think that's always the right approach. For some tasks, you want a deterministic answer that is always the same and it's fully compliant. For some tasks, you may want to be more free and let the LLM do the job, right? So what we do is agents should behave in a deterministic way sometimes for critical tasks and have more freedom in other scenarios. And that's what you can do with our framework. Of course, it's multilingual, visual recognition, embeds things that every company wants today, which is this retrieval augmented generation. So most of our projects today are basically this type of structure where there's a company that has a lot of information internally, and what they want is some type of chatbot that will be able to find the right answer in the hundreds of PDFs that you have accumulated across the organization. So we have this component for retrieval augmented generation that allows to do that. Supports A2A protocol, which again was mentioned this morning as one of the backbones of this Internet of Agents. And we are also now working on basically this personalization part. So the idea is that the same chatbot should behave differently depending on who's the user. If the user is a kid, maybe the chatbot should use a more dynamic and fashionable language. If it's a senior person, maybe it should be more formal. If it's a person that does not understand much of the language, should use simpler words. So the idea is that you can model the user profiles of your agent, and that is embedded into the chatbot, and you get a chatbot that is able to recognize who is talking to and adapt the behavior to that. No, sorry. Thank you for your attention.
Thank you, Dr. Cabot, for that insightful presentation. We have time for one question.
Thank you for your presentation. In fact, I have a question that is also linked to the presentation regarding the Internet of Agents. Now that we are building a workflow with dozens or hundreds of agents, and you mentioned that there is some evaluation that needs to be done, how can you see that we can manage and make sure that the answers are correct when you have hundreds of agents or even trillions of agents that was mentioned in the talk regarding the Internet of Agents?
I mean, you cannot be never fully secure, fully sure about the quality of the answer. That's the first thing. So, because typically what people do is use this LLM as judge to evaluate the first level of agent, right? And of course that helps, but this also generates some kind of threats that now you need to trust the capability of the second level of agents. What I'm going to say is that evaluating the quality of an agent is easier than generating the response in the first place. So it's somehow feasible to use these other agents to check the quality, because again, that's easier than just generating. But then you need to accept the cost. So of course, if you have enough manpower, which are senior people that you trust, then maybe you can go for that. But when this is not the case, you need to somehow accept that by automating the processes, you are more productive, you are more scalable, but the quality overall can decrease a little bit. So there's no, it's always a trade-off. There's no perfect solution.
Okay, we'll take one more quick question.
Thank you. I've really enjoyed that, and it's been a massive eye-opener. My question relates to, my name's Rakea, my question relates to the biases. Currently, as we're all aware, we live in a world that is enhancing from biases bit by bit. In relation to AI, AI is a tool that is going to hopefully facilitate the growth of humanity. The current issue, I'm sure we've all faced it in some way, are biases, myself included. I'm a female with engineering background. I'm not going to let you paint the picture, but it's been a journey just to be here. In relation to the AI models that you've seen, doesn't surprise me. So what would your suggestion be in relation to ensuring we're at the transformational stage of AI, we're at the start of AI, and to ensure that it doesn't impact humanity in a negative way, as I believe we're slowly coming out of the biases bit by bit. I don't want this to set us back.
My unpopular answer would be that sometimes we ask too much of the LLMs, in the sense that our LLMs are biased because society is biased, right? So we want to fix the LLMs, but we know that we are not fixing society. So we want them to be better than us, right? So and that's a tough challenge. I would say that in the last 2 years, since we started this work, they are really getting better and better. So it's less and less biases, because they put a lot of guardrails to make sure that certain questions that they know that people keep asking are protected. But of course, there's always a workaround. So sometimes, especially in political biases questions, if you ask about, again, certain countries and certain wars in the world, they would say, okay, I cannot answer this. So they put a guardrail, but then maybe if you write the name of the country with a typo, then the guardrail is not activated because it's not a perfect match. But the LLM, of course, is smart enough to know that you are talking about that country, even if there's a typo, and then it gives you the answer. So I don't think we can avoid biases because it's inherent in our society. So I think here there's a part of testing them, but also it's a lot about education of the people that they need to be careful when using the models.
Thank you, Dr. Cabot. That was insightful.